seminar. I should, okay, yes. I think it's the 30th in the series, and we have a fascinating topics, constructing a genotypic product space, which I understand it's something about industrial diversification and RTD. And our presenter will be Dario Diodato from the Joint Research Centers, and we have a discussant, Nico Pintar from Austrian Institute of Technologies. The rules of the game are the usual one. Dario will present his ideas and findings for about 35 minutes. Then I will give to Nico the word for discussion and comments. And then we will open for a more general discussion. You can intervene by raising your hand, by opening your camera during the discussion. We are not that many that we cannot have under control. As usual, please mute your micro. And we appreciate if you can keep your camera open, because it's always nice for presenters to see who is around and not just to see black names. So thank you. And with this, I would like to give to Dario directly the word for your presentation. Thank you.
Thank you very much. Thanks for the invitation and the organization of the seminar. Just give me a second to share my screen. And I have to do some tweaks here because apparently Zoom does weird stuff with me. Okay, you should see all fine. Okay. So again, thank you very much for the kind invitation and for the organization of this seminar. I'm happy to present this work, which is a work in progress that we have been at it for a while in different forms. It's actually now reached a very relatively mature stage. We have like an early draft that you can find on my website. But we hope to have a working paper that is a citable working paper before the summer break. So we are just like looking at the final touches. And this is a joint work with Ulrich Schetter, who's at the University of Pavia, Frank Neffke, the Complexity Science Hub in Vienna, and Eric Protzer and Ricardo Hausmann, who are at the Harvard Kennedy School. So to give you a little bit of motivation, I say that the motivation behind this paper, it's the same motivation that lies behind the general literature on the product space, and even more broadly speaking, the literature on economic complexity. And it can be summarized by these simple stylized facts. Here it's a simple bivariate plot where you have on the horizontal axis countries by their GDP per capita, adjusted for purchasing power parity. And on the vertical axis, you have a measure of diversification. In this case, is export diversification. We are counting the number of significant exports that the particular country makes. And you can see that it has a very strong trend line. There is very strong association. This is a cross-section, but actually you can see that happening even if you look longitudinally how country evolves over time. So it seems that diversification is part of the development and growth process. However, this is a fact that is not fully or let's say wholly integrated in the theory of growth and development. In fact, the growth by diversification, which in economic lingo you would call it growth at the extensive margin, is not very well understood. There are like few models that feature this type of dynamics, where like there is an expansion of the diversification, the growth of diversification, expansion of the varieties that are made, or increase in the variety, also in terms of the quality. I have a few examples here listed on the slide, but all these models, they actually think of varieties in a very abstract way. So they are typically modeled as symmetric, and they are placed in a unidimensional measure. Could be variety in a horizontal sense, that they are different type of products, but the difference with them is just based on some abstract measure, or could be like a vertical quality. But we think this doesn't have a very good correspondence with reality. And this is when, like, a seminal paper from Ricardo Hausmann with Hidalgo, Klinger, and Barabasi wrote for Science in 2007, where they noted that countries do not actually, the diversification moves are not random. Countries do not actually move from producing canned goods to microchips. They typically have some process of diversification towards activities that are related to what they already do, and this is gradual. And the landscape of this diversification, which is the technological landscape that allows them to move, it's highly heterogeneous. And what they propose in a very practical manner is to measure this landscape using this concept of the product space, and that would be done by observing how many times a pair of products are co-exported by countries. So, for instance, if you observe that motorbikes and cars are exported at the same time in tandem by many countries, they infer that there must be some technological similarity between cars and motorbikes. And this is not only to draw, design, and depict the technological landscape of exports, but also to predict diversification moves. Because if you then observe, that's the idea, one country that exports motorbikes but does not export cars, then you can use the fact that you know that export motorbikes to predict that it will soon be able to produce also cars. And this is what they verify empirically, that in fact is the case. And the empirical success of the product space is what led to the creation of actually one could say independent stream of literature that also went beyond exports by looking at production, and looking also not only by countries, but between regions, and going beyond the production of goods that are then sold on the market. For instance, Ballan and Rigby look at technology. They build a technology space, and there are in 2019 papers, Pugliese and co-authors, for instance, they look at cross predictions between technologies, production, and science. So in all, there has been like a huge literature that grew out of this seminal paper that sort of shows that it is possible to use co-occurrence to predict the evolution of a technological or a production system. And this is has been dubbed in perhaps with an umbrella term in some review article as the principle of relatedness. So, but and here is where like then finally like our research comes in. The product space, one could see it as a machine learning framework. So it is based on outcome, and it's driven by prediction. So its purpose is like the ability of making predictions of what is going to come next. And it relies on a measure on a measure of revealed similarity. So we do not know what makes cars and motorbikes similar. We just infers that they are similar because we see them, that they are often co-exported. So in a way, it works in a similar manner to some product recommendation system. Just observe whether a user likes 2 movies, and if many users like the same 2 movies, then the product recommendation system would suggest you to suggest one movie if you watch the other one. But to borrow a metaphor from biology, we say that the product space, given these characteristics I just described, is phenotypic in nature, as opposed to being genotypic, in the sense that it's based on outcome and it's not based on what actually makes the products similar. So our contribution is that we design a framework for thinking about the product space in terms of its inputs, which in the literature of economic complexity have often referred as the capabilities, but in general inputs that could go into the production process, and so a framework that we then name a genotypic framework. And we essentially propose 3 steps to this framework, 3 things that this framework can do better than the current state of the art. Is we propose a measure of similarity that counts missing capabilities according to a product capability network. So we start directly from the observation of what type of inputs go into a product. And we show that we can use a strict interpretation of this framework to infer a country capability matrix, so to figure out which inputs are present in which country. And finally, once we have a list of requirements of product and a list of capabilities of countries, then we can see how close a country is to a product directly by counting the capabilities that it already has and the one that it's missing. And this is a framework that can be used with any data on product capability. But for this paper, we actually take the framework to the data using particularly occupations as a measure of the capabilities that are used in the production of a particular industry. So I will show you some empirical results of some empirical application of this framework. Just to give you a little bit of sense of the previous art, there were attempts before or efforts, let's say, to measure similarity between products by looking directly at capabilities. Some of these was work I actually did myself in the past. However, the measure that was used, they were used, like I have a few, like try to summarize the type of measurement that were used is either like using flows between of inputs between products and industries, or correlations between requirement vectors, or using concurrence across countries in one specific case. What we contend is that this does not, including my own precedent work, does not fully exploit the possibility that are given by a genotypic perspective that really looks as the inputs that are used in the production of a product as sort of like the genetic code is what you need to produce that. And I'm gonna show you during the presentation exactly what I mean with that. This is actually a follow-up from another paper I co-authored with Ricardo Hausmann and Ulrich Schetter, that are both also co-author of this paper, in which we have built a formal economic model of growth by diversification. So that's as I was sort of describing in my earlier slides of the motivation, this growth by diversification into a heterogeneous landscape is not part of the bulk of the mainstream of the theory of economic growth or a theory of development. The product space sort of fills this gap, but it was not formalized in a language that is a formal economic model. So that's what we do in this paper. And in this paper, what we find is a theoretical result, essentially, that countries are more likely to enter into industries that require fewer tasks that are not present in industries that are already existing in the country. And to arrive to this finding, we conceptualize proximity between a country and an industry in terms of its required task. And this conceptualization, sort of the step that lead us to the paper that I'm presenting today, which is that building on our previous work, we expand into a generalized framework of the product space based on the required inputs or capabilities. Okay, so let me get into the framework. In order to conceptualize this framework, we use the notation that Ricardo Hausmann and Cesar Hidalgo used in the Journal of Economic Growth paper of 2011, in which they summarize the word of economic complexity broadly with the simple equation you see here. So you have 3 elements to this equation, which are 3 matrices: MCP, CCA, and PPA. MCP is a matrix of 1 and zeros. People who are familiar with the literature would recognize it immediately. It takes a value of 1 if a country C is active significantly in product P, and it takes a value of 0 otherwise. While the other 2 matrices on the right-hand side of the equations, they are the endowment matrix and input requirement matrix. So CCA would tell me with A as an index for an input or a capability. The matrix CCA tells me whether a country as input, country C as input A, and it would become 1 if country C has input A and 0 otherwise. And same with PPA would tell me would be a matrix of 1 and 0, which would tell me whether a given product requires a given input or capability. And the idea is that the specialization of countries, specialization, diversification of countries, so the MCP matrix, the left-hand side, what countries do, will be determined by the right-hand side through a process that is not entirely known. So that's like this O dot operator you can see there, sort of say a combination of the input requirements and what countries have, they would determine what countries can do. And the idea of the majority of the economic complexity literature and the product space specifically is that you can just forget about the right-hand side, which is too complex, just do things on the left-hand side. So do things phenotypically and measure the product space. Here in particular, you have the seminal measure by looking at the co-occurrence. So that would be a product matrix between the MCP matrix and its transpose, divided by some normalizing factors. And the majority of the literature of product space and economic complexity is based on this idea, this co-occurrence in space of the left-hand side of this process. But in our work, we propose a framework that suggests how you can start exploring the right-hand side, in particular, starting from a product capability matrix. So the first step is actually relatively simple. You take a product capability matrix that would tell you what inputs are required for what products, and we propose a measure that is essentially a substitute for the product space that tells you how similar the products are in this space, but compared to what was proposed in the past, with a better, it's a measure that allows for a more meaningful interpretation, because what I have on the numerator is the number of inputs that are required by both product P and product P prime. So we look at the list of inputs and we look when they are actually required by both, but as a share of what are already present in product P. So that would be a proportion of the inputs that are required. And this can also be augmented in order to account for input intensity. So if we know that a particular input, like for instance, to build cars, you need the 30% of the workforce are actually engineers, mechanical engineers, then we can use this information by weighting the requirement matrix, second requirement matrix in particular, for this information. And so this would give us a measure of similarity between products or industries. based on the input requirement matrix. Then the second step that we propose is that we can actually infer the endowment matrix. So which kind of inputs countries have. And this we do it, we have to do it with some assumptions. The assumptions are that the product capability matrix that we have is an actual representations of what is required. And this is not innocuous assumption, because obviously there can be some variation in the production process across countries, for instance. And also we'd have to assume that the capability A is non-tradable and non-substitutable. So this is also like something that guides us into the choice of the data that we want to look at, because the inputs that work in this framework, they need to be input that are either non-tradable or hard to trade, and of course non-substitutable. So and for this reason, it's actually why we look at primarily at occupations, because there are laws that prevent from migration. So migration is not something that is frictionless, and also like they are very specific. It's hard to substitute an engineer. There is no substitution rate between an engineer and a financial analyst. It's just two different things. You can substitute them. So with this assumption, what we can do is infer the presence of capabilities from production. So if we do have a matrix of production, MCP matrix, we can just infer that if a country is able to produce something, and we know that these things cannot be substituted and cannot be imported, then this country must have this capability that is required. So the formula over here, it's an indicator function. So it says it takes a value of 1 if any of the products that use the capability A are actually in the production basket of country C. This is how we infer the capabilities. And the third step is actually then what we use to predict whether a country, what we could use to predict whether a country will become active, will diversify in the future in a given product. In the standard phenotypic approach, you would do this step by using a measure that is called density. Essentially, you have like the product space that tells you how products are similar to each other. You're trying to predict the appearance of product P. Then you would look how many products P prime the country has that are very similar to product P. And this is the density formula, for instance, that is proposed in Hidalgo et al. 2007 in the original product space paper. But our framework allows for a more direct measure. That's what we show here. That as a meaningful interpretation. So what we indicates is the share of inputs that are required by product P that are already present in country C. And also in this case, and this is actually our preferred measure, we can weight it for the intensity of the input. So if you see like the multiplication of the numerator and also the multiplication you see in the tilde version, which is the augmented version, since these are matrices of 1 and 0, so you get a 1 into this summation only if the input is both required and present in the country, and then this it gives you the share of inputs you already have on the total that you need. So this is the framework, and the framework can be applied to any MCP matrix combined with any product requirement matrix that would be this PPA matrix. But we have an analysis based on one example, and what we do is we use trade data, because this is where the bulk and the origin of the product space and the complexity literature actually has been using predominantly. I mean, there are other data sources, but of course this is the most standard you could find in the literature. So we wanted this as our starting point, And we use so UN trade data to construct an MCP matrix with the exported commodities between the year 1992 and 2016. And we then take labor statistics data from US Bureau of Labor Statistics. In particular, we use occupational employment statistics that gives us information on which kind of occupations are needed for which industry. And as I anticipated earlier, we focus on occupation because it is a quintessential non-tradable input of production. It's probably the least tradable input of production. It also captures, in some dimension, some tacit knowledge that it's hard to trade for. And then, of course, they are not the trade data are in HS classifications, while BLS data use NAICS classification. So we have to do some concordances to then arrive to our final data set that has 88 4-digit NAICS industries, 444 6-digit occupations, and from SOC classification, and 140 countries. Sorry, was there a question? I thought I heard something. Okay, so with this, we can map our product space that comes from our genotypic framework. And this is a depiction of it. What's interesting about this depiction is that we have a direction compared to previous depictions. We have a direction because there are industries that require few occupations. The industry that requires fewest occupation is leather and hide tanning. And there are industries that require a lot of occupations. Navigational instruments, in this case, is the one that requires most occupation. So actually the nodes, the position of the nodes in the x-axis is based on the number of occupations that they require. And obviously, like it is it's always easier when you have an asymmetry between the number of occupation. It's always easier to go in one direction compared to the other. So we actually show the arrow only in the direction which is hardest, because the other is implied. So you see that this is with this depiction of the product space, you can see development as the process of going from the left-hand side of this space to the right-hand side of this space. And you see that there are like, it shows routes, some of which they are like dense in agricultural and primary material extractions, while others they are more dense of manufacturing. You have like the textiles here, and then you have the chemicals and the machinery. So it looks like these could give like can give like a qualitative description of different growth paths that have actually been observed in the world, where some countries that ended up specializing in agriculture and primary extraction did not have a long-term sustainable growth compared to those that actually developed in textile and then moved on into other more complex activities. Obviously, we can check how this space correlates with the phenotypic product space. We find it's a high correlation. But most interesting, we want to look whether it is able to predict appearances of new industries in the future. And that's what we do with this, what we show in this graph. Like we have a non-parametric estimation that kind of gives a sense. With the gray dots are the estimates done with the traditional phenotypic density from the regular product space, and with the red is our estimation with the genotypic product space. They are, you see, as they are comparable, which actually it's to our surprise, because what we thought we were losing a little bit in predicting power to gain in understanding, but it looks like we are not losing too much in predicting power, because we see that in both cases around we move from 1 to 3% to 5 to 5/7%. in the probability of appearance. So if you are on the left-hand side, so if you have a low density, it means that you do not have many similar like the industry that you are trying to enter into is not similar to the one you already have. In one sense, phenotypic, and the other genotypic. While on the high value of the horizontal axis, you have that is very similar. In our case, it means that in our case you have cases where you have all the occupations that are required for an industry that you don't have yet. And if you have all the occupations that are required for an industry you don't have yet, your probability goes from 2% to 7%. So it's like almost more than a threefold increase. So that's quite significant even economically. And you can also see that we have a more monotonic. I think this happens because we have our measure avoids double counting. So you don't, at some point, if you have many industries that use the same skills, you would double count them in a phenotypic measures. Well, in this case, since we know the genetic code, what is that the industry use, if like motorbikes and cars use the same occupations, there is the information from cars does not add too much to the information of motorbikes if they use the same occupation and you're really counting motorbikes. Naturally, this is just an indication, but we can do this more formally with the regression model. On top, you have like the estimating equation, which allows us to control for all sorts of dummies, and we find that this is robust to more structural estimation. And also we can see, like in the last set of estimation, we can see that even when we include both the phenotypic and the genotypic protospace, they both stay significant. It means they do not capture exactly the same variation. So there may be value also like into using both. Okay, so by the timer I still have 5 minutes. So I think if I don't go into much details, I should be finishing on time. This, we think, like the strength of this is that it opens up many possibilities and it has strong implications. So let me try to quickly discuss a few of them. The first implication is that now that we think about capabilities, we can enhance research using information about capabilities. So just to make a quick example, we have made in a paper, we have enhanced regressions in which look at the years of educations that are required for a given occupation. And this could be used, this is the rec, could be used to integrate what you know. So you're looking at what is the average number of years in this particular case of education that is needed for the capabilities that are missing for that particular industry. And indeed, we find an effect. So this is a way in which our approach can enhance the research on the product space in general. It can help understanding development paths as accumulation of capabilities. So here we show just 3 simple plots in which we show that countries that they grow, they increase the number of capabilities, but the capabilities they add, they are less general. It means that they are used in fewer industries, and also they are rarer. They are present in fewer countries. This gives you like some new information about the growth process. And also can shed light about poverty traps. We identified 3. I don't have the time to describe them, all of them, but if you have a question, I'd be happy to go back to. Perhaps I can show the periphery trap. Some of these poverty traps are not new. They're just like we shed new light. For instance, the periphery trap, we can use the actual genotypic product space to make a simulation about the growth prospect of countries, given the industry of they start with. So if we imagine like the development process starting from a number of different industries, and we can show that these are like several simulations, 10,000 simulations for each of the starting point, and we show that in some case, for instance, footwear manufacturing, it's most of the time it leads to a sustained development, while in case of tobacco manufacturing, it doesn't. So this is something that it depends. So you have these poverty traps in which it depends whether your initial specialization allows you to do it. This will determine the long-term perspective of growth in the country. And this, of course, can help you also like reframe development policies, because instead you can directly ask which capabilities you need for a given industry, or which capabilities would give you access to more industries given your current state. So there's an implication in the way we could think of how we use the product space to design policies. Next step, this is we think is just the first step. There's like so many directions we would like to go that we think we are actually in front of a research agenda. Some possible future directions, but we even have in mind more, is like we can test capabilities, so we can empirically verify what are the constraints to diversification, because we have seen that occupations are a constraint to diversification with our analysis, but perhaps there are other capabilities that are other capabilities or other inputs, perhaps even intermediate inputs. They could be a constraint to diversification. We can use this framework to empirically verify that. Of course, we have had an assumption of a homogeneous production process, and we also have an assumption that we are not in a world in which you can take the production process and fragment it into different sub pieces. So this is also something that we'd have to think about in future research. How these we have some robustness already to show that like our results hold if you, for instance, use a technology from another country, but we definitely might want to analyze this into more depth. Then we could look at what happens in regions and cities, if this is also like a framework that could explain the diversification of regions and cities. And of course, this is the product space side of it, but we could develop and analyze also complexity indices based on these new matrices. So just to wrap up, as I mentioned, research of economic complexity. Actually, I didn't mention this before, but this is perhaps it was a bit implied in my talk. When the product space focuses on output, but the theoretical motivation behind it is actually often coming from a theory of capabilities. So it talks a lot about theory of capabilities, but instead it focuses on output. And this is justified because indeed it is possible to infer useful information from output, given its focus on prediction, it's also like it's useful to do so because it allows to do predictions with minimal data requirement. However, we think like this is what I'm hoping to convince you of, is that there is much to learn to study capability directly, and for this, while we are not the first to look at inputs, I think we built a framework that allows many further research direction into the understanding of capabilities in the context of product space and diversification. Thank you very much.
Thank you for this fascinating presentation, which is dealing with something extremely new for me, but that makes even more relevant. Could you stop sharing your screen?
Yes.
And then I would like to give the word immediately to Nico. then I have myself questions, and for sure there will be many questions from the audience. But Nico, the word is to you for first rejoinder.
Thank you very much, Benedetta. Thank you very much, Dario. This has been very interesting to me. And it has been a great presentation. I read your paper with a lot of interest. It has a lot of also effect and maybe implications for my own work. So that was really a good choice that I am here chosen as a discussant. I will quickly share a few slides. If I find it. Here. So I hope you can see that. You see that, right?
Yes, we see it.
Okay. So I will start with some short summary and the main points I find interesting. Then I will go into a little bit, maybe some limit. There are not a lot of limitations I saw in the paper, but some. And then maybe some future points where you could go and where I have some clarifying questions, etc. So I think, as I already said, this is very interesting work, and it basically starts with rethinking the very basis of economic complexity literature and the basic approach of how you can then capture complexity and these kind of structures from the data. I'm repeating a little bit, but maybe it's also helpful for the audience to hear it again. So rather than inferring similarities between products, from collocation, the proximity between products, you estimate them directly from the overlap of capabilities. So you look at the capabilities directly, and then you basically can define the proximity or similarity between products by specifically looking at the overlap of capabilities that these products need. And with that, it is then possible to then map these alternative versions of the product space and then also calculate density measures, which you then used in your entry model, and that you showed that it has an additional explaining power in addition to the phenotypic density measures that have been used so far. And this is also touching very much my own work. I've seen these measures in so many papers, so I can really attest to the fact that this is highly used. So it's very interesting and welcome to have a new version of this, or an advancement even. So the key advantages of this approach, in my opinion, is that you can directly identify the missing capabilities. From the phenotypic approach, this is not as easily done. So typically, if you have a suggestion to diversify into a certain kind of product, or also in the technology space, in a certain kind of knowledge field or technology, then this is not tied to a specific recommendation of, okay, you have to strengthen this capability to achieve that. It's just, okay, this would be easy, so maybe you can go into that. So that's a very advantage of this approach, that you can identify. Of course, you could, in theory, from the phenotypic approach, you could, if you know that you have to go into this kind of product, and then if you have the information of your of your matrix that links the products to the capabilities, you could, of course, also in the phenotypic model, then look up the capabilities that you're missing. Maybe it's not the same, but it's an indirect way of where you could still do that. And the second key advantage I see is you didn't touch on this in your presentation, I think, but the asymmetric proximity between products. So in the phenotypic world, I think you gave an example in the paper of maybe going from airplanes to some clothes or something like that. So it is, of course, very much easier to diversify from a complex product to a not so complex product. But in the typical phenotypic approach, this is not really seen. It cannot be. So that is another interesting part. So possible limitations. The big thing, and this is also, I guess, why this has not been done more often. It has been done a couple of times, but not more often, is how do you measure these capabilities? And what kind of capabilities can you even measure? So you have chosen to use the occupations in your empirical example. This makes a lot of sense and it works well. But in these theoretical arguments of the economic complexity literature, often capabilities are understood in a broader sense. So they would also entail knowledge, skills, industrial practices, institutions, etc. So all the things that we want to know, but we cannot really measure. So you are trying to do that, but with things you can measure. So of course you are losing some of this explaining power and these theoretical arguments. And I'm wondering if you are missing an important piece of the puzzle when you're limiting yourself to these measurable capabilities. So that is one point. Maybe you can go a little bit into that. And because I think that the strength of these phenotypic approaches is exactly this indirect approach, that of course it is not as well explained, but it has a lot of explaining power, and it captures many things that are not measurable that easy. So that's that's that. And some more detailed questions and further ideas is on the page 16. I think you already maybe answered this. You compared the two slopes or the two lines of the density measures, and I'm wondering how you would explain this nonlinear and linear, more or less linear line in the genotypic density, and what are the implications of the difference and possible extensions and future avenues. You have already said that there are many paths you can go, but in my opinion, the most straightforward, or maybe the most interesting to me, is that go to the regional level and to the city level, and also maybe look at technological capabilities. And if you do that, then spatial spillovers will have much more of a role to play than if you look at country data. And I was wondering, and also this, we know that, I was wondering that if you could extend in your model also external capabilities and maybe tradable capabilities, or if this doesn't make any sense, or if this could be a possibility, because current literature and policymakers, they call for these interregional cooperation, especially in innovative activities. And I was wondering if that would be possible to integrate. Yeah, and with this, I give the word to you or to other colleagues in the call. Thank you.
Yes, thank you for these comments. I suggest we give Dario 5 minutes to respond, and then we go to the broader audience. Maybe could you stop sharing the screen?
Okay, thanks, Nico. These are very good comments. I think like you capture the main points that we were trying to make well. So that's good. That it means that we are communicating in the right direction. And indeed, the strengths are the one you mentioned. Including the asymmetric proximity, which perhaps I didn't fully stressed. I just mentioned it briefly during my presentation on when I showed the depiction of the product space that I show that between nodes I have arrows that go from one node to the other, and the reason is indeed that it is always easier to go on one direction than go into the opposite direction, because there is an asymmetry in the number of occupations that that are required by the two industries. So if you see an arrow in one direction, the arrow in the opposite direction is implied. It's always easier if you can go in one direction to go in the other. So that's definitely one of the strengths of our approach. In terms of comments you made that I'd like to respond. You said you could potentially look up at the capabilities from the phenotypic approach. So you could use the phenotypic approach to then identify an industry and then look at the capabilities that are required to that industry. This is possible, but what we claim is that the process of identification of the industry, if you do it in the phenotypic sense, you may miscount some capabilities. So you may actually have identified the wrong industry, because, and the reason is this this non-linearity, which we think it comes, they both come, like these two issues, from this double counting. So the issue, when we identify whether a country has a certain capability, we look, for instance, you know, motorbikes, does it use mechanical engineer? Yes. Cars, does it use mechanical engineer? Yes. So countries have mechanical engineer if you have either of those. But in a phenotypic approach, you would count twice, because you would be able to see that they are using the same capabilities, even though it's the same capability. So what we think is that this issue like may distort the results of the phenotypic approach, while we may control for ours. We can actually have the problem ourselves too, if say mechanical engineers and electrical engineers use actually the same skills. So another idea is to extend the approach to go even deeper, not at the maybe at the task level or the skill level, so looking within an occupation, because we may have some double counting if two occupations are using the same type of knowledge. So this is, I think, like a way in which we also improve on the existing methods. And we don't claim we have solved everything, but we claim we have a framework that allows you to think about that and try to solve it then empirically the best way you can. Try to quickly answer also like the rest of the comments. It is true that we limit ourselves to measurable capabilities, but again, we have a framework that allows a lot of flexibility. So I think what is needed to be done next is to test which capabilities are relevant, and perhaps, like, you know, some are difficult to measure across countries, and but maybe like there is some data set that allows you for some country to measure that capability, and somebody can do a research on that and tell us whether this capability is relevant or not, and then we can try to integrate, eventually perhaps create an integrated data set that tells us what capabilities are needed for a given industries, and that is as broad as possible. But I agree that in general, this is the shortcoming, like the trade-off of like trying to understand more, is that that then you have like the things that are captured by co-occurrence, which sort of like grabs everything together, maybe some of it might be lost. So this is a little bit the trade-off. Fortunately, we see that in terms of like prediction capacity, we are not too far off. But obviously, if you then take a product space approach and you optimize with a super strong machine learning algorithm, I think you would be doing better in terms of predicting the activity than what we are doing. But we can provide a better understanding. And I'm almost out within my 5 minutes. Let me see. I think like what is yes, I think like the regional point. This is a very good point. The fact that possibly what is constraining at the national level may not be the same at the regional level. So I think we'll have to also have this, not only testing the capabilities, but testing the capabilities at different scales, see which one are actually constraining countries and which one are constraining regions, and see if they are the same. And because it's true that you could, in some sense, like trade capabilities. And this also goes for countries in some sense. And we don't have an explicit extension, but we might have an explicit extension for trading capabilities, because now we are in a revise and resubmit with the previous paper, which is the theoretical one. And we were asked to think about this. And actually, we believe it's not that different, because our model suggests, in our model, we think of entering a new industry as acquiring the skills on the occupations that you don't have, let's say. So you're missing 3 occupations, you need to acquire the skills. In our model, you acquire the skills by learning by doing. So you have somebody who doesn't have the skill, who goes there and learns that particular occupation. This means that the country is able to produce that particular industry, but it will be inefficient, because there will be a production penalty, will be a cost of learning that particular capability. If we think of, instead of like learning by doing, that capability is acquired by, taking a bunch of engineers from Germany, putting them on a plane and flying them to the country once that the capability, that could also be modeled in the same way as a cost of as an extra cost you would have to incur to produce that product in the country. So I think from a modeling point of view, is actually you would say isomorphic. So it's kind of the same model. So I think we are, even if there is some tradability, but the tradability is costly, we think that our framework is still valid.
Thanks very much.
Thank you. I would like to open the floor for questions. I have myself a couple of questions, but if there are questions from the audience, they should have priority. Thomas.
Yes, maybe I can. I just wanted to thanks Dario for the wonderful presentation. I think that the main point lies indeed to transfer your wonderful theory to a proper empirical application. And I think that the point you mentioned about the non-tradable capabilities, I think, is one of the main points that you should address when you search for empirical applications, because this is the whole literature about knowledge diffusion, knowledge spillovers, more or less is neglected when you speak about non-tradable capabilities. And I think this is really important that you should be taken into account for future applications in a policy context, but also in the context of empirical analysis of industrial diversification. And for that, I think you really need to come to a measure that can be applied at the regional level, as you have it on your slides anyway, because the capabilities within countries, in particular in large countries, are so distributed unequally, and they are localized in geographical space, so that when you measure that at the country level, this is averaging out. It's more or less like averaging out geographical space, right? As we would be in an aspatial world, and I think this is really something that could be taken into account for empirical applications, regardless how you measure capabilities. So you see, you have embodied spillovers, but also disembodied spillovers. It's not only taking a bunch of engineers from one place to another, but it's also about what Nico mentioned about the collaboration networks and knowledge spillovers that come from these networks. So the positioning of regions and countries in these networks may extremely change their capabilities and their potential for diversifying into related industries. And I think that's important to be taken into account for future empirical progress in that respect. Just a comment and not a question. Sorry.
Thanks. No, oh, sorry. Go ahead.
Yes, go ahead.
You want to collect more questions before I answer,
or no? I think you can.
Okay. Thanks very much, Thomas. Yes, indeed. I think you raise all valid points. In terms of the transformation from the theory to the empirics, in particular, like to our theory based on non-tradable capabilities. Maybe like we have to rephrase our work as in from non-tradable to costly tradable, because as I was mentioning, indeed we do not require the capabilities to be completely non-tradable. We just require them to have a cost that is way larger if you have to import these capabilities that if you have them while they are already there. And in this sense, it's also like an extension could be, and we're actually thinking about that, could be also looking at whether the capabilities are near you or not, or whether like, you know, like your openness as a country to trade actually makes the probability of acquiring capabilities higher to begin with. Because maybe if you are potentially, if you are a close country is close to trade, this is more important to you than if you are a country that is very open to trade and you are in the center of Europe. So it's sort of like perhaps easier to import the capabilities. There is no impediment, legal impediment. There will be language impediment, but there's no legal impediment to get the right occupations from other countries. So yeah, we are thinking in that direction. That's because indeed it's a very important point, and this may be also relevant subnationally. That we might be mismeasuring a little bit because perhaps we predict the appearance of an industry because it's a combination of two capabilities, but these two are one in the very north of Italy, the other in the very south of Italy. So actually the distance to the industry is larger than we measure because there is a cost to combine them.
Thank you, Dario. Next question. So I do have a question looking from science technology studies. My question is how R&D comes into play, because there are lots of works on R&D specialization, for example, on R&D capabilities, portfolios of scientific knowledge, and it seems to me that you cannot rule out of your models R&D because it's a source of capabilities in many sectors. I don't know whether this can be integrated into your framework or.
Thanks. This is a difficult question. It's a difficult question because it's a little bit of a change in perspective in the sense, okay, there is two things about it. One in which it can be clearly integrated and one in which it cannot. So it can be clearly integrated if you think of the output of R&D as an input in the production. Right? So R&D often generates innovation that is often captured in patents. So you could think of patents as an input to an industry. You could like go ahead and collect data on, could use perhaps, you know, match, use what's like called Orbis IP. You have like information on of firms, like which are the patents that they have. So you could sort of map which kind of patent classes are used for which kind of industry, and then you can apply the framework and see if that gives you a signal or not. So can you predict the appearance of new industries based on the fact that you have patents that are used in that industry that you don't have? So it is possible to extend it this way. On the other hand, this is the part in which I think it would fit perfectly, and it would be a way to integrate innovation, research and development and innovation into this framework. On the other hand, there is a part in which it doesn't fit. That is, this is, and to some extent, the product space in general is sort of a catch-up framework. So you are looking at technologies that exist, and how countries that they don't have the technology, they catch up to that technology. And while often when you're thinking about R&D, you're thinking about moving the frontier, doing things in different ways. And this is the part that I don't think this is the right framework to think about that. I think if like R&D comes in a way that, for instance, substitutes away like a number of occupations, because now they can be done by an AI assistant, then of course it changes the input requirement matrix of an industry, and this is something that that is not what this framework is doing.
Okay, thank you. Fair enough. So if I understand well, it's basically a static framework in terms of technology, or
yeah, let's say it's a lagged framework. Like we have tried like different years of the technology matrix to see that indeed like this works. But what we're mostly looking as, okay, given the state of technology in 2016, whether you can predict the evolution of countries that do not have that technology into certain industry. This is the way we would think about it. And this you could like keep updated as time goes by, but you would not use this framework to see how it is updated.
okay, thank you. Fair enough. Other questions? Seems no. I had a feeling a whole world opened into my mind with your presentation, so thank you so much. This was really appreciated. We all live of broadening our horizons, and you know, I'm a scholar mostly in public science, and having an idea that these frameworks exist more on the production side, it's really valuable. So thank you.
Thanks.
And thank you to Nico for your very precise points.
Thank you.
We will have still another seminar to go before summer break. This will be still about technology, but it will be on the development of new technologies in regional co-inventor networks based mostly on patent data. So we are moving to something more near to the technological development. And time will be 12th of June, same time as today. If there are no further comments, I think we can close here the meeting. And I wish you a pleasant afternoon.
Many thanks again for the invitation and for the comments.
Thank you to you.
Thank you.
Bye-bye.
Bye-bye.